Okay, so now this video will record also, right? Okay, so till now what we have studied, that we had studied about the little about the magnetic field, how the past and the history of the magnetic field, and then we discussed little about the magnetism, and we discussed about the a small m, and then we also discussed about the capital M. Capital M is, what is this? Tell me, what is capital M and a small m?
Capital M is magnetic dipole moment, or a small
Yeah,
m is a strength of the magnet.
yeah, it is similar like charge, right? It is similar to electric dipole, right? And it is vector quantity and it is a scalar one. And we had also saw that if we have a two magnet, one in this way, and here is angle theta, then what will be the magnitude of these two, that we have also seen, right? And also we have seen, so this resultant vector will be at phi angle, right? So what will be tan phi? That's also we have covered in the last class. Anyway, moving to the ahead, so next topic we have magnetic field and the strength of the magnetic field. That means magnetic field, which will be denoted as B, and that is the vector quantity similar to the electric field, right? And a strength of magnetic field, that means how a strength is it, right? So that we will cover in these two, right? Okay, so it is similar like electric field. So one thing I would like to tell you all guys, that suppose it is electric field in x direction, right? It is electric field, and magnetic field in this direction b, right? And suppose this is z direction, right? It is y and it is z, right? These all are perpendicular to each other, right? Perpendicular. You can assume the corner of a room where you can find x-axis, y-axis, and z-axis, right? So electric field and magnetic field is always perpendicular, right? When I say about the electromagnetic wave, like suppose we have a sun here, right? From sun we are observing that light is coming, right? So light is nothing but electromagnetic wave. So why it is so? Electric, that is electric field, magnetic, that is magnetic field, and it is behave as a wave, not as a ray, right? So it's acting as a wave. So electric and magnetic, right? So electric and magnetic field always perpendicular to each other, right? You have to keep this thing in your mind. And another term which will come in picture, that is the polarization. It's, or we will cover in induction chapter, right? So here just to, I want to relate with electric field to the magnetic field, right? Anyway, so come to this point. So here the physical space around magnetic poles has a special influence due to which other pole experience a force. Here it is telling that if we have a magnet and we have a pole north and south, so because of these pole we feel we feel experience a force, right? एक force हमें अनुभव होता है, right? The special influence is called magnetic field, right? We feel that something is there. What is that something? That named as magnetic field, right? There is a magnet here and something around this, right? And that something is field, something, yeah. This is area, right? This is field. Like if you say uh like it is, like you say, suppose there is a leader like Mukhya ji, right? If you say Mukhya ji, so the field of Mukhya is a panchayat, right? So the effect or the power of Mukhya ji will act only in this region, right? So that we say field, right? So same thing is here. We have a magnet here, and because of this magnet, there is a creation of a field, right? Where we feel attraction or we feel repulsion. That means a kind of force, right? So that is called magnetic field, right? And the force is called magnetic force. Clear? Like we have a magnet over here and magnet, and because of this magnet we observe or experience something, right, around it, right? and this something is filled, right? Because of this magnet, this field is created, right? So that is called magnetic field. And then we experience some force because of this magnet, so that is called magnetic force. So it is as simple as it is, we can understand in this way. So moving next here, so now we have a strength of magnetic field, right? This field is qualitatively represented by a strength of magnetic field or magnetic induction or magnetic flux density. So it is very important to you should understand that these words, these different words have same meaning, right? Same meaning, because while solving the question you will find that these words are used at different places with different names, right? But the meaning is same. Either you are telling about the strength of the magnetic field, that means magnetic field is how a strength it is, kitna mazboot hai magnetic field, right? That is the thing. Magnetic induction, magnet induction means something like I'm teaching to you, right? And you are taking coaching anywhere. So teacher teaches a student, right? That means induction of knowledge, induction of knowledge there. Like, in the childhood, mothers generally, mother, teaches to her girl, or yeah, daughter, how to cook food, right? So that is induction of knowledge, right? So same thing is here, magnetic induction. That means there is a property of magnetism, or there is something which is characterize the magnet, right? So that property will get induced in other material or other things, right? So that is induction. That means transfer of character, right? If suppose it is A and it is B, right? And property of A is getting transferred in this, so we will get induction, right? This is the way. And magnetic flux density, right? We will understand about the magnetic flux density. Like in electric field, you understand about the electric field, something like that, electric field lines, right? Electric field line, right? So suppose we have this cross section area, right? So from this cross section area, how many lines are coming out from this area, that is called flux, right? So if lines are too much, yeah, so many lines are coming out, right? So many. So we will say, it is high dense, right? And if in this cross section area only some number of lines are coming, so we will say flux density is low, right? So flux means how many lines coming out from a unit cross section area or something like that. We will describe there, and you can relate with the electric field. In electric field, no, you had studied about these, flux, right? Same thing is here. Here you will find magnetic field lines, not electric field lines, right? But things are similar. So now, what is the definition of magnetic field or a strength of magnetic field, right? It is represented by vector B, right? So if I say B vector, so what is the mean? It is showing that a strength of magnetic field or magnetic induction or magnetic flux density. So B vector means these three names can be recognized the B vector. Okay. So now try to understand how B will be defined, right? How B will be defined. So later here. So here look at B is defined by like this, right? Okay. So like here, just to think, this is a magnet, okay, and I should read these sentences so that it will more clear to you all guys. The magnetic force experienced by a north pole of unit polar strength at a point due to some other poles called source is called the strength of the magnetic field at that point due to the source. The thing is, support is in north and it is south, right? And suppose there is a other magnet, it is south and it is north. So this north is, this point will feel force because of this. We know, south and north will attract and north or north will repel. We had discussed in last class, and already guys, right? Okay, so now here, suppose this point is feeling force because of this F force, right? A force. Okay, and the unit, you can see here, the magnetic force experienced by a north pole unit polar strength at a point due to some other poles, means the value of m is equal to 1 for this pole, right? And this pole is feeling force, right, or experiencing force if because of this magnet, that is the source, that is called a source, right? So because of this magnet, this north pole is feeling force, experiencing force F, and the magnitude of the strength of this pole is 1, right? If condition is this, right, if condition is this, then B will be equal to the F. Like M here become 1, M is equal to 1, then B is equal to F. So what is B? So B is force when M is equal to 1. Are you getting my point? That means this pole is experiencing force F and its M is equal to 1, then that force will be equal to the B. Got it? So that is the definition of B. तो यहाँ पे अगर किसी को दिक्कत है तो पहले पूछ लो, क्योंकि ये समझना बहुत जरूरी है, आगे जो न्यूमेरिकल आएंगे उसमें ये बहुत जरूरी है समझना। तो यहाँ तक किसी को दिक्कत है तो बोलो, क्योंकि शुरुआत यहाँ से हो चुका है ना। तो टेल मी एनीवन।
नहीं आया सर हमको।
नहीं आया? ओके,
नहीं।
मगही में बताना पड़ेगा का? देखो इधर चलो
Yes.
मगही में थोड़ा बता देता हूँ। लुक एट हियर, सपोज ये मैग्नेट है और इसका नॉर्थ है और इसका साउथ है, ठीक है? इसका जो एम का वैल्यू है वो 1 है इसका, और यहाँ पे कोई दूसरा मैग्नेट है, ठीक है, नॉर्थ और साउथ इसका है। तो ये साउथ है, ये नॉर्थ है, तो ये अट्रैक्शन फील करेगा। अगर ये नॉर्थ या साउथ होगा तो ये रिपल्सन फील करेगा। तो इस पे जितना
Yes.
फोर्स वो फील कर रहा है, राइट, तो ये जितना फोर्स फील कर रहा है वही फोर्स बी के बराबर हो जाएगा, क्योंकि एम हम 1 ले रहे हैं। तो एम का वैल्यू अगर तुम 1 कर दो, हटा दो इसको, तो बी और एफ सेम हो गया ना।
Yes, sir.
हाँ, इसका मतलब क्या हुआ कि जो बी का वैल्यू वही है जो एफ का वैल्यू है। मतलब ये है
Yes, sir.
कि ये जो पोल है, एक यूनिट पोल स्ट्रेंथ जिसका 1 हो, वैसा पोल जितना फोर्स फील करेगा वही मैग्नेटिक फील्ड का स्ट्रेंथ हो जाएगा। आर यू गेटिंग माय पॉइंट?
Yes.
और कोई जिनको समझ में नहीं आया? क्योंकि ये समझना जरूरी है, आगे एक एक चीज समझते चलोगे तो आगे तुम ऊपर तक चले जाओगे, और यहीं से अगर कंफ्यूजन होगा तो बाद में तो फिर मामला ही गड़बड़ हो जाएगा। तो और किसी को समझ में नहीं है तो बताइए, या जिसको जिसको समझ में आएगा वो बताओ कि यस आई गॉट। चलो जिसको जिसको समझ में आएगा वो बताओ यस, बोलो यस।
Yes.
Yes, sir.
Yes, sir.
ओके गुड। सूरज आज 8 हुआ है, राइट?
Yes, sir.
हाँ गुड। और तुम्हारा तबीयत ठीक है बाबू? योगा नहीं करोगे तो बीमार ही रहोगे खैर, come to this point. So F is magnetic force on pole of pole strength M, right? It is F is a magnetic force, pole strength M, and M may be positive or negative. M may be positive or negative. It is similar to the electric field Q. It may be negative or it may be positive. So S sin of B is Tesla. So what is Tesla? You can see here force, that is Newton, and M, right? What is M? So let's we discuss about that. So let's firstly discuss over here wave per meter square. Wave per meter a square, that is called Weber, or meter square, that is called Tesla, right? You know, unit of magnetic field, that is Tesla. I think this kind of question come in the board examination. So magnetic field so what is the real over here? You can check here the force Newton. And what is Newton? 1 Newton equal kg per meter, sorry, mass into acceleration, meter per
Meter
second a square,
square.
right? So this is Newton. And what about m, right? So m is like where we find that Coulomb, right? In charge we have a Coulomb. Okay, so here can write F is equal to m according to this direction. Positive pole, 1 minute, positive pole north pole will be in the direction of field, and m negative pole north, so it will be a positive direction of B. Yeah, this thing I know, sorry, we know. Negative pole, like here B is in this direction and it is in, and F is also in this direction. So I'm just discussing from here. So B, M is positive, you can see here BF is equal to M into B. So B is a vector, suppose this is B vector, right? Okay, and what happened if I take M is equal to -2, right? So -2 means what? Whatever vector over here, that will become 2 times if m is equal to 2. So that means it's become, the length of B is this, so now it will become double of this. But now here it is minus, so it will become opposite, right? So instead of going in this direction, it will go in this direction. Are you getting my point? So here you can see B and F is in same direction. It means M is positive, right? M is positive, and positive pole we go for north. We had discussed in yesterday class that means what do you say, positive for north and negative for south. Same thing is here. B is in this direction, and if we take M negative, so you can see here M is negative, so F will be opposite of B. So now F is just opposite of B, right? The field generated by sources does not depend on the test pole for its may value and any sign. The thing is very clear. Test pole means what? Try to understand this, that is very important. Test pole means let me write. Suppose we have magnet here and it is north and it is south, and test magnet is this. Here it is north and it is south, right? So here suppose it is north, right? So test pole, that means this pole is feeling force because of this south. So this is what he said here, test pole. So this is test pole, right? Test pole is over like here. So here that's written here, M is positive or M is negative. M is positive or M is negative. So that's depend on this one, right? So either M is positive or negative. So that's written over here. The field generated by sources does not depend. The field generated by sources does not depend on the test pole, right? That means about this, मतलब इस पोल का जो एम का वैल्यू है उस पर डिपेंड नहीं करेगा, इस पे जो फोर्स है वो. आर यू गेटिंग माय पॉइंट? यहां से जो फोर्स पैदा हो रहा है वो इस बात पे नहीं डिपेंड करेगा कि ये नॉर्थ है कि साउथ है, वो फोर्स का वैल्यू उतना ही रहना है. दैट इज द थिंग, राइट? एनीवे, सो इरेज करने का लफड़ा. तो लेट्स मूव अहेड. तो यहां तक क्लियर हो गया. वी हैड डिफाइंड द मैग्नेटिक फील्ड विद द हेल्प ऑफ फोर्स, राइट? ओके, Now B due to various sources. Now the question arises, there are various way to produce magnetic field. So some of them we will discuss, right? So how can we produce magnetic field? The question arises कि अच्छा एक बात बताओ, मैं इंग्लिश में बोलता हूँ तुमको समझ में आता है कि नहीं, ये बताइए सभी।
यस सर, आ जाता है समझ में।
ये मंटून और सूरज तुम लोग बताओ, बोलो।
हल्का होता है इसका,
हाँ
पूरा नहीं समझ में आता है।
हाँ, तो भैया इंग्लिश पढ़ाओ, इंग्लिश गाना सुनो, इंग्लिश मूवी देखो। भोजपुरिया से काम ना चली भैया। चलो देखो, नो लुक एट हेयर। लो, मैं इंग्लिश में इसलिए बोल रहा हूँ कि तुम्हारा लेवल उठे, ठीक है। हमको इसको मगही में पढ़ाने में मजा आएगा, बट इससे तुम्हारा लेवल नहीं उठेगा, राइट। मैं हमेशा तो तुमको नहीं ना पढ़ाऊंगा। तो once if you get level or potential, you will understand, you can understand to anyone, right? बट फिजिक्स समझना है, फिजिक्स समझाने के लिए मैं मगही में भी आ सकता हूँ, ठीक है, उसके लिए कोई दिक्कत नहीं है। बट नहीं समझ में आएगा तो जरूर बोलना कि सर ये समझ में मेरे को नहीं आया, राइट। बेईमानी यहाँ पे नहीं होना चाहिए, यहाँ पे कोई प्रॉफिट लॉस की बात नहीं हो रहा है, हम लोग पढ़ रहे हैं एक मिशन के लिए, राइट। सो मिशन में कोई धोखाधड़ी नहीं। एनीवे, कम टू पॉइंट। सो बी ड्यू टू वेरियस सोर्सेस। अब मैग्नेटिक फील्ड कैसे पैदा होगा? जैसे एक चीज अभी हम लोग देखें कि एक मैग्नेट है, तो मैग्नेट से मैग्नेटिक फील्ड पैदा होता है, तो ये तो एक सोर्स हो गया, ये एक पैदा करने वाला सोर्स हो गया। अब और इसके अलावा और क्या क्या सोर्सेस हो सकते हैं टू प्रोड्यूस मैग्नेटिक फील्ड, राइट। सो फर्स्ट इज ड्यू टू सिंगल पोल। ड्यू टू सिंगल पोल, व्हाट इज दिस? Similar to the case of point charge in electrostat. Like in electrostat we have a q charge, so because of q charge we have electric field all around it, right? सूरज कुमार भाग गया था। सूरज, आर यू इन दिस नाउ? आर यू इन द मीटिंग? सूरज, हेलो। सूरज, आर यू इन दिस मीटिंग? सूरज, I think yes. Okay. Okay, now so look at here, we have a aim. So similar to the electrostatic charge, we have a q charge and electric field all around this, right? So similar here, it is aim, okay, it is something like pole, and here it is distance r, right? So you can see here b is equal to mu naught upon 4 pi m r square. It is similar to kq upon r square, like kq upon r square, right? It is similar to that. B is here, so this is magnitude, this is magnitude, okay. And direction of B due to north pole and due to south poles are shown in the vector form, this, right? So it is complete formula of magnetic field strength. So you can see here, you can see here, this one is here, right? So this is magnitude, right? So magnitude means was, I can write this formula in this way, like look at here, mu naught upon 4 pi m upon r square, right, into r vector upon r, right? So what is this? Tell me anyone.
Unit vector.
Yeah,
Unit vector.
unit vector. That means vector r divided by magnitude of r, right? So that is unit vector, that is unit vector, right? So it is here. So what we have learned about the vector, what we have learned? So we learned that suppose we have vector a equals, suppose 3x cap plus 4y cap, suppose it is this, right? So this is vector. So what is the magnitude of this? So 3 and 4, that is 5, that is 5. So we will divide by 5.
Yes.
So it is
I-
unit vector, it is unit vector, right? That means its magnitude is 1. Its magnitude is 1, right? So here you can see here. So here you can see it is only magnitude. It is magnitude, right? Magnitude of magnetic field strength. Magnitude of magnetic field strength. But it is in vector form. It is in vector form, right? So vector form means it is a scalar one. This is the magnitude, and this is unit vector. That is direction. We know now vector quantity means magnitude and direction. Magnitude and direction. So if I write a vector equal to 3I cap. So what is the mean? The mean is vector A is in x direction. I matlab x direction. So x direction. और how is magnitude? That is 3. That means ये कितना लंबा है? तो 3 है. किस डायरेक्शन में है? तो I डायरेक्शन में है. तो कितना लंबा है? मैग्नीट्यूड बता दिया. किधर है? तो x में है. तो ये डायरेक्शन भी बता दिया. Are you getting my point? So that is same thing here. So this is magnitude, मतलब उसका स्ट्रेंथ कितना है, कितना उसका वैल्यू है, मैग्नीट्यूड है. एंड दिस इज डायरेक्शन, मतलब किस डायरेक्शन में है. ओके. सो इसमें किसी को दिक्कत है तो बताइए. इसमें दिक्कत है किसी को तो बताइए. नो. 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 ओके. सो लेट्स मूव अहेड. अब एक चीज यहाँ पे एक समझ में आ रहा होगा तुम लोग को कि भाई हमने तो बोला था मोनोपोल एग्जिस्ट ही नहीं करता है, राइट?
यस सर,
एग्जिस्ट नहीं करता है
दूसरे
तो नहीं करता है, वो बात सही है. बट यहाँ पे मैं क्या कर रहा हूं कि ये फॉर्मूला को बस हम डिराइव कर रहे हैं मानकर कि ऐसा है, ठीक है. बट एक्चुअल में इसके साथ तो दो दो रहेंगे. एक्चुअल में क्या होगा, एक नॉर्थ होगा तो दूसरा साउथ भी होगा, तो इसके कारण भी फील्ड होगा और इसके कारण भी फील्ड होगा. आर यू गेटिंग माय पॉइंट? राइट. तो ये मान लो नॉर्थ है और ये साउथ है, तो इसके कारण यहाँ पे जो होगा इसी कारण यहाँ पे वही होगा. तो हम लोग बस फार्मूला डिराइव कर रहे हैं एक को मानकर, बट रियलिटी में एग्जिस्ट नहीं करता है, राइट? ओके. क्लियर है यहाँ तक?
Yes.
Yeah, don't you have to confuse. So look at here. So it is north pole. So north pole we know positive and south we know negative. So and similarly to the minus q charge and plus q charge. Are you getting same thing? Same thing. It is going outward and it is coming inward, right? And r is position vector, right? R vector, that means it is position vector. Position vector means suppose it is origin or any place, and from here how much distance. So it is at R, this value is R, and direction in this direction, that is called, it is R vector. So you know position vector, I don't think you don't know. It's all right. ठीक है, यहाँ तक क्लियर बोलो.
यस सर.
यस. हाँ यस यस बोलते रहना ताकि गाड़ी आगे बढ़ते जाए, नहीं तो फिर स्लो हो जाएगा. तो एक चीज समझ में आ गया. एक तो हम लोग ये देख लिए कि मैग्नेटिक फील्ड कैसे हो रहा है, तो मोनोपोल से. किससे? मोनोपोल से. बट एक्चुअली मोनोपोल एग्जिस्ट नहीं करता है, बट हम मान के चले. तो जैसे ये नॉर्थ और साउथ दोनों है मैग्नेट में, तो हम इसके कारण ऑब्जर्व कर लिए, तो सेम चीज इसके कारण भी होगा. ठीक है, समझ में आ रही है बात? कंफ्यूजन नहीं होना चाहिए कि भाई मोनोपोल तो होता ही नहीं है तो ऐसे ऐसे क्यों बता रहे हो. मोनोपोल नहीं होता है, सही बात है, बट एक मोनोपोल के कारण ऐसा हो सकता है. बट अब डाइपोल के केस में हम लोग कंसीडर करेंगे कि दोनों रहेगा तो क्या होगा. ठीक है, तो देखिए यहाँ पे अब सेकंड केस इज बार मैग्नेट, राइट? बार मैग्नेट. सो बार मैग्नेट मीन्स कॉम्बिनेशन ऑफ साउथ एंड नॉर्थ पोल, राइट? एंड you can also say magnetic dipole. Magnetic dipole. Di means two. तो magnetic a magnet है and dipole because south and north there are two dipoles. Sorry, two poles are here. So here it is again same as the case of electric dipole. in electrostatics, right? आप एचसी वर्मा के बुक में जाओगे वहां पे ऐसे दिखाएगा ये वाला, यहाँ पे प्लस क्यू चार्ज, यहाँ माइनस क्यू चार्ज, ये एंगल थीटा दिखा देगा ऐसे, और यहाँ से डाइपोल के केस लेकर के पोलराइजेशन निकाला है। तुम क्लास 12th का जो एचसी वर्मा पार्ट 2 है उसमें जाके देखोगे तो पोलराइजेशन कितना होगा, डाइपोल मोमेंट कितना होगा, तो डाइपोल मोमेंट निकालने के लिए ऐसा फिगर बनाया है, प्लस क्यू माइनस क्यू चार्ज, and it is at angle theta from this axis, right? And this oscillates, right? This oscillates, and because of oscillation we have, you know, angular frequency omega, right? And sham occurs here, right? So these things will come in picture, and I request to you all guys just to go to HC Verma second part book and trying to understand about the same thing is there, same calculation you will find there, right? And that we are going to do here right now. So next, so look at here, look at here. हाँ हाँ सूरज कुमार, तुम ऑडियो क्या है ना बंद रखो, नो पीछे से आवाज आ जा रही है। जब तुमको पूछना होगा या मैं जब पूछूंगा तो तुम पूछना, ठीक है? ऐसे बंद रखोगे, राइट? ओके ओके, नाउ कहाँ था मैं? या सो देखो, नाउ लुक एट हियर, वी हैव अ मैग्नेट, राइट? M and minus M is polar strength at N and S, and you can see this is magnet over here, something like that, and it is perpendicular axis in this way, and here we are trying to find magnetic field, right? So because of this magnet, and between this, what will be the value of magnetic field here, right? So it is called equatorial plane, है ना? Equatorial plane line. So this is equatorial line, and this is axis, right? Axis of the magnet. Okay, so we have two point here, it is B, and here it is A, 2 point here and here. So we have to find magnetic field this point and at this point. Same thing we had done in case of electrostatic. If we have a, and also in dipole, suppose we have a plus q and minus q, right? So it's become a dipole, and because of dipole, what will be the electric field in this and at perpendicular line? So at two place we able to know, and also we can calculate here also, if it is at angle this one theta, so it is general one, here theta is 0 and here theta is 90 degree. So if we calculate dipole moment or electric field at any angle theta, so we can also calculate here and here, because in this case theta becomes 0 and in this case theta become 90 degree. So same thing is here. So here we are trying to calculate the magnetic field at axis at distance r, and at a vertical line, that is equatorial line, at distance r. So distance is r into case, and the length of magnet is 2a. In the dipole you also know plus q and minus q, plus q and minus q, you will find the distance between d is 2a, right? We can also take a, no problem. Why they take 2a? Because the distance from the center becomes a and a, so that there is no need of any confusion. Why 2a? So the logic is very simple, so that from center to the pole distance become a, that is the reason, right? So now a on the axis, on the axis, what will be the value, right? So that value is 2 mu naught by 4 pi m r cube for a less than r. That means the magnet is very small in comparison of this, right? अच्छा, अभी टाइम खत्म होने वाला है, मैं फिर से एक लिंक भेजूंगा, राइट? तो ये जैसे खत्म होगा मैं एक लिंक तुरंत भेजूंगा वैदिकुलम का जो ग्रुप है उसमें, ओके? So I should hint this.